Hey everybody, Nick Espinoza, your chief security fanatic here, and today we are talking about the future of tech, because the future of tech is your sweat. I'm not kidding. Here's what's going on. This is absolutely fascinating, and this is coming from Science Mint. Now, nano engineers at UC San Diego have built a quote-unquote wearable microgrid that basically harvests and stores energy from the human body to power small electronics. Now, it consists of three main parts: basically a motion-powered device called a triboelectric generator, sweat-powered biofuel cells, and energy-storing supercapacitors. Now, all of these parts are washable, flexible, and can even be screen-printed onto clothing. Now, this wearable microgrid is built from a mix of flexible electronic parts that were created by the nanobioelectronics team of UC San Diego. Basically, their professor, Joseph Wang, and he is also the director of the Center for Wearable Sensors at UC San Diego and the author of the study that I am talking about here. Each part is screen printed onto a shirt and basically put in a manner that optimizes the amount of energy collected. So I'm guessing the more you sweat, the more it can store. The wearable microgrid was tested on a subject during 30-minute sessions that consisted of 10 minutes of either exercising on a cycling machine or running, followed by 20 minutes of resting. The system was able to power either an LCD wristwatch or a small electronic display, basically a device that changes colors in response to an applied voltage throughput, basically of each 30-minute session. Now, these biofuels are equipped with enzymes that trigger a swapping of electrons between lactate and oxygen molecules in human sweat to generate electricity. And obviously, this is in its early stages. We're talking about small devices, but I think this application is just, like I said, beyond interesting. Now, again, Joseph Wang here and his team first reported about these sweat harvesting devices, these wearables, in 2013 in a paper, and working with colleagues at the UC Center, UC San Diego Center for Wearable Sensors, they later updated the technology to be stretchable and powerful enough to actually run electronics. Now, the triboelectric generators are made of negatively charged material placed on your forearms and a positively charged material placed on the sides of your torso. And basically, as the arms swing against the torso while they're walking or running, the oppositely charged material rubs against each other and then generates electricity. Each wearable provides a different type of power. The biofuels provide continuous low voltage, while the triboelectric generators provide pulses of high voltage. And in order for the system to power devices, these different voltages need to be combined and regulated into a stable voltage, and that's where the supercapacitors come in. They act essentially as that reservoir that temporarily stores the energy from both power sources and then discharges it evenly as needed. Now, all of these parts are connected with flexible silver interconnections that are printed on, let's say, a shirt, for example, and insulated by waterproof coating. The performance of each part is not affected by repeating bending, folding, crumbling, or even washing in water, although you can't use detergent on that, as obviously it would start to degrade that casing. Now, this particular system is useful for things like athletics and other cases where the user is exercising, but this is just one example of how a wearable microgrid can be used. And to quote one of the authors of the paper, "We are not limiting ourselves to this design. We can adapt the system by selecting different types of energy harvesters for different scenarios." Scientists are obviously working on other designs that can harvest energy while the user is sitting inside an office or basically moving slowly outside. So your couch potato butt watching 12 episodes of Netflix something in a row might actually be able to generate enough electricity at the moment to, let's say, run the Xbox controller you're playing, or the remote control, or store energy for use, let's say charging your cell phone as maybe you hold it, or you put it in your pocket or something like this. There's a lot of different applications that can be used or that we can think of for this. Not to mention other devices that might be able to charge. Maybe the rotating wheel of a tire or something in a car essentially could start charging the battery if we apply this, let's say, to the backside of the wheel. So it's not hitting the ground, but let's say it's got that negative and positive charge. And here we are charging our batteries, or let's say reducing the amount of charge our batteries need. This is fascinating technology that we have here, but wearable devices are the future. And it's not just, funky glasses or VR cameras or watches or even rings or anything like that. It's the clothes that you wear that may actually just generate electricity without you having to plug into a grid. And that seems like that's an ecologically very feasible thing to do. Obviously, the production of these, I don't know what the impact of is, but this is fascinating technology, and I thought you guys would really enjoy that for today. And so that's your news. And please like, share, follow me here on Facebook and Twitter at NickAESP. And please feel free to subscribe to me at YouTube as well. And as always, stay safe and stay online. Thanks, everyone.